Sorry about that. It appears we lost power. And welcome back. So, after checking things out, it would appear that we're supposed to use these percentages to dictate what part of 180 that is. The problem is, this says, when are you likely to do a majority of your back to school shopping? This is a probability. This isn't telling us what percentage of 180 we're going to do. So we have an assumed average here, and we're supposed to assume this is the percentage of spending per month, but it's worded very poorly. And it's that kind of wording that makes this hard. When are you likely? That's a probability that says you have a 24% chance to do a majority of your spending in June. You have a 46% chance to do a majority of your spending in July, a 22% chance to do a majority of your spending in August, and an 8% chance to do a majority of your spending in September. It does not say this is a percentage of 180. So unfortunately, the closest we can get is we can do substitution and figure out that July, if it does equal 80, but that doesn't make sense because that includes September, was to equal 90. This example honestly is terrible. We're going to scratch this whole thing out. Going on to example 2, using distributive property. So we're doing distributive property kind of differently here. We're going to be adding a negative number to make our lives easier. So this becomes 500 minus 5, so we get 495. For 4 times 1,002, all right, this would be 4,008. So what they're doing here is breaking down the mental math to try to make you understand it easier. This is 4 times 1,000 plus 4 times 2. So we have 4,000, and 4 times 2 is 8. 4,008. Estimate the value of 7 times 51. All right, so we got to rewrite that as 7 times 50 plus 1. If we do it this way, 7 and 50 make 350. So 751 will make 357. Oh, it will be a little bit bigger than 350. Yeah, it's going to be bigger. It's going to be 357 because there's one more 7 added. Which expression uses the distributive property to rewrite and find the exact value of 7 times 51? Nope. We know it's 357. Nope. Let's just cross out the bad answers. 500, absolutely not. 500, absolutely not. This works. B and E. How can you use distributive property to evaluate and rewrite the expression 8 times 1,100? Well, you can rewrite this as 8 times 1,000 plus 100 to get 8,000 plus 800 to get 8,800. That one's a little easy, in my opinion. Coefficient is the numerical part of a term. So if we have a coefficient, it is the numerical part. Coefficient, 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 coefficient. Like terms are terms that have the same variables with corresponding variables having the same exponents. An expression is in simplest form when it is replaced by an equivalent expression having no like terms or parentheses. Distributive property and the properties of equality can be used to show that 6x plus 2x equals 8x is an expression. 6x and 2x are like terms. We use the distributive property. That's 6 times x and 2 times x. We've pulled the x aside. 6 plus 2 is 8. 8x. These are equivalent expressions. 3. use the distributive property to solve. All right. So doing our rewrite from here, we're done. Oh, I see. They want us to do it. So now we have 20x here minus 28. They are the same. All right, check. Distribution. So we're going to get negative 6r, negative 18g plus 6t. Simplify the expression. Let's see. Let's see. Simplest form, especially when it is replaced by equivalent expression having no like terms or parentheses. Well, they're... Oh, it wants us to find the simplest form. I got it. That's... I'm looking at this the wrong way. That's A. Four, distribute an algebraic expression from the right. All right, so they gave us 3y squared plus y minus 8 quantity times 6. So go from here to here. We distributed the 6 to each term. We multiplied the coefficient by 6, and we're done. And that is it for the notes today. Thank you so much.